One perceptron is not able to separate complex data. But then when you're combining these perceptrons together and you are making a multi-layered perceptron that has hidden layer in them, they are going to be able to separate complex data. And now I'm going to show you how. So for example, if I have a data that looks like this, and then circles here, I can just draw a line and I can separate these two from each other. Okay, so one layer, so single perceptron is totally able to do that. But imagine, I'm going to make this a little bit longer. So imagine I have another set of triangles down here, and these two are the same thing. So right now I cannot draw just one line to separate this data from each other. So a single perceptron is not able to separate this data. So this is, we're considering this is Y and this is X. Okay, I need to make this smaller because I have a lot of stuff to show you here. So this is going to be our original data. I have Y and X, and then there are triangles here, there are circles, and then there are triangles again. I'm going to create a multi-layer perceptron, and let's see how a multi-layer perceptron is able to solve this problem. So I have two inputs, X and Y, that are going in, which each one of them are going to show the position of each one of these data points, okay? Because as we said, the input is going to be the features of the data, and it's not going to be the actual data. Each one of these data is coming one by one into our network. So our features are going to be X and Y here. And then I'm going to give it one hidden layer. So this is, I'm going to have two perceptrons in my hidden layer. So this is my hidden layer, but since I want to show you how it works, I'm going to give each one of these hidden layer a number. Our multi-layer perceptron is going to get it perfect in one shot because I want to show you how it works. But in reality, it's going to have to try several values until it will come up with a perfect line to separate this data from each other. And also, we're talking about non-linearity later. And I'm going to give it a single output. So these are my inputs, this is my output. And then it's going to be fully connected. So I'm going to connect all of these to each other. And this is my output. So these are my inputs, this is my output, this is my hidden layer. So we couldn't come up with a single line to separate these data from each other. As we said, we cannot use the perceptron here. The first hidden layer is going to be able to separate the triangles from the top and the rest. So it will say, and it will able to tell the difference between top triangles and the rest. And the second hidden layer is going to be able to tell the difference between bottom triangles and the rest. And for our output, we want to say if it is a triangle or if it is not a triangle. Okay, so when you are, now if you look at it, our output does not have access to input. There is a hidden layer between these, okay? So each one of these hidden layers are going to transform the space of our data. So we don't have access, in our output, we don't have access to our original input. So it is incorrect if we just say, oh, so there are two lines, each one of these hidden layers will give you two lines and separate this in original space. This is wrong. So many people make this mistake thinking that there are going to be two lines that separate the original data, but that's not what really happens. Because as you can see, our output does not have access to our input. Our output have access to the hidden layers. So hidden layers are going to transform this space. Let's just remove this incorrect one. Perceptron 1 in the hidden layer is going to take X and Y, and it's going to separate the data, the triangles from the top to the triangles from the bottom. And it has access to the original input because the original input is going to come in. So I'm going to say Y and X. And my line here is going to be this, okay? So, and then I'm going to say this is hidden layer number 1. Sorry, this is perceptron. This is perceptron number 1 in the hidden layer. Okay, so now we're going to perceptron number 2. I'm going to put it down here. This is again Y and X because it's still hidden. Perceptron number 2 still have access to the original data. So this is perceptron number 2, and number 2 is coming up with this line, okay? And then what's going to happen is it's going to say everything on top is going to be 1, everything in the bottom it's going to be 0, okay? And then for number 2, again, we're doing the same thing, but the top is going to be 1, the bottom is going to be 0. So it's basically like true and false, okay? And then we're going to look at the output. Output is going to be the combination of the hidden layer. Output is going to be a combination of hidden layer number 1 and hidden layer number 2. And since here we're not using the activation function, we're not using the nonlinear activation function, we have to come up with just one line to separate these. Because right now our data is very simple. When you're looking at the more complex data like image or something like that, you need to apply some nonlinearity, in order to be able to separate the data. I'm going to explain that later. So right now, my space is going to change, and it's going to be the perceptron hidden layer number 1 and 2. So I'm going to draw it here. So this is going to be a perceptron 1, and this is going to be perceptron 2. We have zeros and ones. Just for simplicity, I'm going to put 0 here. 0, as you know, is here, but I want to show it better, so I'm just going to put 0 here. And then I have 1, and I have 1 here. So these are going to be for 1, 0, 1, 0. So 0, 1, 0, 1. Okay? And I'm going with the first data. Imagine the first data is going to come in, and we want to say if, we want to see where the position of this triangle is going to be in our transformed space. Okay, so this triangle and all of these triangles are going to be in perceptron number 1. This triangle is going to be number 1. So I'm going here, and I'm looking at the perceptron number 1. I'm looking at the perceptron number 1. And this triangle is at the position 1. So it's either going to be here or it's going to be here. And then I'm going to the second one, and I see the triangle is still in the position number 1. So I'm coming here, I'm going to position number 1 in hidden layer 1, and I'm going to position number 2 in hidden layer 2. In perceptron 1 and perceptron 2. So my triangle is going to be here. And all of these triangles are going to be on top of each other here because they are in position 1 and 1 in both. Okay, and then I'm going to look at the circles. Circles in perceptron 1 is going to be 0. So perceptron 1 is going to be here. So in perceptron 1, my circle is going to be, in perceptron 1, my circle is going to be somewhere here. And then in perceptron number 2, my circle is going to be 1. So my circle is going to come here. Okay? And then I'm looking at bottom triangles. And I see that the bottom triangle in the first perceptron is 0. So it's going to be here. And then in the second perceptron, again is going to be 0. So my triangle is going to be here. So now, as you can see, I can just draw one line and separate these two data from each other. And then I'm going to say whenever you're getting 1, it's going to be a triangle. Whenever you're getting a 0, it's going to be a circle. So right now I want to know if it's a triangle or not. So true, triangle, false, not triangle. So the whole point here that we are looking at is that when you're having multi-layer perceptron, you're not separating in the original space. You're not separating your original input space. You're separating in your transformed space. And that is the combination of the hidden layer. So this is how multi-layer perceptron works.